Hello friends, we at ST Online Campus are discussing an important topic of TPMS, which is canonical cover. Okay, what does it mean? Canonical cover is minimum number of FDs. Okay, minimum number of FDs means in an FD set there can be redundant FDs, that FDs which can be derived from another FDs. So the canonical cover purpose is to remove those FDs from FD set. For example, for a given relation student, we have two FD set, FD1 and FD2. So we can see that these two FDs have three FDs are same. Okay, three FDs are same in this FD set. The different FD is SID is determining S country. So we will see whether we can determine this FD from FD1 or not. So SID closure using FD1 is SID, S name, S state and S country. That means using SID I can determine S country using FD1. That means this FD is also present in FD1. This means all FDs are present in each other. These two FD sets are equivalent. So canonical cover is this FD1 because it has minimum number of FDs. So to find the canonical cover from FD set, we will follow some process. The process is, first we will use decomposition rule. Decomposition rule, what does it say? Say that X is determining YZ will be decomposed into X into Y and X into Z. In this FD set, we can decompose this FD. So the FD set will be AB is determining C, B is determining D, A is determining C, A is determining D, AC will determine B and AC will determine D. B will determine C. Now we will see whether we can remove any attribute from left hand side of an FD. Removing attribute from left hand side. Okay, so if we see this FD, AB is determining C, we will see whether there is a relationship between A and B, whether A can derive B or B can derive A. So if it is so, we will remove those dependent attribute. So if we see AB, whether A can determine B, no, there is no FD determining F. A is determining B. B is determining say A, this is also not there. That means this FD will remain same as of now. B determining D, A determining C, A determining D, AC determining B. We will see whether there is relationship between A and C. A is determining C, so that means this FD is present. That means this can be decomposed into A is determining B because C is already determined from A. Next, here also I can write A is determining D, B is determining C. Now we will see whether we can decompose this because A is determining B is now present. So from this I can remove B. This will be A is determining C, B is determining D, A is determining C, A is determining D, A is determining B, A is determining D, B is determining C. Now we will remove those FDs which are redundant. So A is determining C is redundant, we will remove. A is determining D is also redundant. So after step 3, FDs will be B is determining D, A is determining C. These two I have included. Next, A is determining B, A is determining B, A is determining D. And These two I have included. Remaining is B is determining C. B is determining C. Now we will see whether there is a transitive dependency. So if it is so, we will remove that as well. So A is determining B, B is determining C, A is determining C. So from these two, I can determine A is determining C because of transitivity. A to B, B to C. So we will remove this. So it will be B to D. Now we are removing transitivity. And A to B will be there, A to D will be there, and B to C will be there. Now A can determine B, B can determine D. So using these two, I can determine this. So this is also redundant. It will be A is determining B, B is determining D, B is determining C. So these are the FDs in canonical cover of these previous FD set. So all these FD set intermediate are equivalent to this. So this is the minimal FD set. Okay, thank you.